Hello, welcome to this e-learning module. Exit. You can click on this to exit the module. Transcript. Learning is always fun, isn't it? The industrial water system consists of many more processes. I hope you clearly remember and understood about the previous module we learned. Let us recollect it once. We have learned about sources of water, types of water in steel manufacturing industry, and also about few processes like bar screening, sedimentation, and also about equipments like clarifier, settling tank, and pressure filter. This module will enable you to get an idea about water softening and lime soda softening. Explain about ion exchange, in which we will learn resin classification, cationic exchangers and anionic exchangers, ion exchange resin, regeneration, describe reverse osmosis, duration, in which we will be learning about oxygen scavengers, case study of TM plant at pH 5, disinfection,
हाँ हेलो, गुड आफ्टरनून। वो फ़ोन कर रहा था ना कि रबर पैड का वो ऑर्डर प्लेस करना है, ठीक है? 10।
कौन सा वाला?
जो हम लोग वहाँ दिए थे ना, क्या नाम है, ये राउंड राउंड दिए थे कि वो दिए थे?
इससे पहले आपने स्क्वायर वाला दिया था।
इससे पहले स्क्वायर वाला दिए थे। नहीं तो
राउंड वाला किया आपको?
ये
आपको गोल पैड दिए कि स्क्वायर वाला दिए?
यहाँ पे कौन सा गया था सर? टोयोटा में, हेल्थे टोयोटा में।
इस डेटा कहाँ की बात कर रहे हैं?
रांची।
मुझे मालूम नहीं है।
अच्छा, तो खाली इसका पैड का करेंगे तो हो जाएगा ना ऑर्डर?
आपके पास स्क्वायर वाला तो है ना, चौकोर वाला?
चॉपर वाला तो अभी के रिमेनिंग कितना बच रहा है?
10 पीस आया था।
अच्छा,
देख लीजिए, नहीं तो फिर राउंड वाले का पार्ट नंबर बता देते हैं, आप कर दीजिए ऑर्डर।
ठीक
ऑर्डर बना के भेजना है।
ठीक है, आप मुझे व्हाट्सएप कर दीजिए, ठीक है?
और उसके साथ साथ जब करेंगे उसका तो आप और भी कुछ काम ऐड कर लीजिएगा कंज्यूमर।
जैसे में
जैसे ड्राफ्ट टेबल हो गया, ये ठीक है, एक दो पार्ट और कर लीजिएगा।
वो मतलब बहुत जल्दी निकलता है क्या?
बहुत जल्दी नहीं निकलता है, लेकिन मतलब 2-4 महीने बाद जरूरत पड़ती है।
तो फिर अभी जो है पैसा जो है अकाउंट में है नहीं, ठीक है, और वो लेगा भी नहीं।
अच्छा,
तो
तो ठीक है, आप पैडी ले लीजिएगा, कोई दिक्कत नहीं। मैं
चलिए,
आपको पार्ट नंबर भेज रहा हूँ।
ठीक है, थैंक यू।
कोरोना वायरस या कोविड-19 से आज पूरा देश लड़ रहा है, पर याद रहे हमें बीमारी से
किसका? कौन चीज का अपडेट पूछ रहे हो, ये तो बताओगे? फिल्टर का जो है मंडे को ये होगा, ऑफिस इसका मंडे से खुलेगा।
ऑर्डर लगा कि नहीं लगा उसको?
नहीं, अभी नहीं लगाया।
बात हो गया कुणाल से?
हाँ, कुणाल से बात हो गया।
बोल रहे थे डिस्कस करते हैं मंडे को।
हाँ बोले हैं, तो कहे कि अभी तो हम लोग खोले ही नहीं है, मंडे से खोलेंगे। अभी फिर आप मेल कर दीजिए क्या क्या चाहिए आपको, तो फिर मंडे को मतलब उसको हम ही करवाते हैं। बस ठीक है, हम भेजे हैं, इनवाइस बना के भेजे हैं 2 का, ठीक है? रायता का और इसका कार्लो का।
कौन नंबर
देखो ना कौन सा नंबर का। जियो पे है।
Before learning about water softening, let's see what is water hardness exactly. Water hardness. Hardness is defined as the concentrations of calcium and magnesium ions expressed in terms of calcium carbonate. They react with soap and produce a deposit called soap curd that remains on the skin and clothes, and because it is insoluble and sticky, cannot be removed by rinsing. Thus, hard water is one that does not produce lather with soap. Measurements of hardness are given in terms of the calcium carbonate equivalent. Water is considered to be hard if it has a hardness of 100 mg per liter or more as calcium carbonate. There are two types of water hardness, temporary and permanent. Temporary hardness is due to the bicarbonate ion being present in the water. This type of hardness can be removed by boiling the water to expel the carbon dioxide. Permanent hardness is due to calcium and magnesium nitrates, sulfates and chlorides. This type of hardness cannot be eliminated by boiling. Permanent hardness of water is removed by ion exchange method in an ion exchanger. Since it is important to remove hardness from water, we have opted the water softening process. Softening is the removal of hardness from water. This is not a required part of the drinking water treatment process, since hard water does not have any health consequences. Rather, minerals are required for taste and health. In addition to being unsightly,
हेलो,
और है ना ये नंबर ऑफ पार्सल 3 है, ठीक है, तो कंप्यूटर को अपनी नंबर ऑफ पार्सल लिखते हैं ना।
देखो 3 अलग अलग इनवॉइस बनेगा जिसमें से 2 बना चुके हैं, तीसरा का तो मैं एड्रेस अभी कंफर्म नहीं किया हूँ।
हम अभी राइटर बेटा की बात कर रहे हैं,
तो राइता का
पार्सल 3 है, ठीक है ना,
3
नंबर
मतलब
ऑफ पार्सल में लिखोगे ना, अरे नंबर ऑफ पार्सल कौन वीडियो लिखना चाहिए तो समझ लो, लिख देना। जैसे जाता है तो मटेरियल को पूछता है नंबर ऑफ पार्सल कितना है, मिला लेते हैं पैकेट पार्सल जो बोलो, ठीक है, वो लिख लेना। दूसरा ये है कि टैंकर मोटर का भी कंफर्म नहीं हुआ कि कोई जाएगा कि पटना जाएगा, ठीक है। उसके बाद कार्गो दिखा का कंफर्म हो गया और पैसा टोटेगा। 2 मशीन अभी निकलवा दो और एक मशीन जो है वो कल कंफर्म हुआ तो मंडे मॉर्निंग निकलेगी, ठीक है।
अच्छा,
ठीक है।
the reaction of hard water with soap results in excessive use of soaps and detergents. Upon heating in a heat exchanger, unlike other solutes, solubility of soluble minerals decreases with rise in temperature. As a result, they precipitate on inner surface of tubes, forming scale. This scale is very non-conductive to heat transfer and decreases overall heat transfer from heat exchanger. This may result in overheating of tubes that can cause tube failure. So, there are few processes by which softening of water can be done. There are 3 types of softening treatment: chemical precipitation, lime soda softening, zeolite process, and reverse osmosis. The first process in water softening is lime soda softening. Have you ever learned about lime soda softening? If no, let's learn it now. In this process, calcium and magnesium ions are precipitated by the addition of lime and soda ash. Following are the reactions that take place in this process. Kindly note down them. Calcium hydroxide,
हेलो,
when added to
हाँ सुनो ना, ये 2 मशीन जो है अलाइनमेंट मशीन वो मूव करेगा रांची से, एक पटना और एक जो है यहाँ बोकारो, ठीक है। तो मार्च को हम इनवाइस भेज दिए हैं, तो उसको ये कर लेना और उससे गति का जो है ये पूछ लेना, क्या नाम है उसका, ट्रांसपोर्टर आईडी। अच्छा सुनो ना, जो हम बताने के लिए हम फोन किए हैं हम उससे ले लेंगे। ये बोल रहे हैं कि जो है ना जिसको पहले आया है माल वो पहले निकालना, ठीक है ना। कैसे पता चलेगा? एक काम करो, सीरियल नंबर जो है ना इससे ले लो, अमित जी से ले लो, अमित जी के पास होगा, ले लो। अरे तो हमको क्या मालूम भैया, सीरियल नंबर तो चिपका हुआ रहता है ना, जो उसके साथ आता है वो उसके साथ रहता है, थोड़ी ना मेरे में आता है। वो तो पीडीएफ में जो आता है उसमें सिर्फ डिस्क्रिप्शन रहता है। हाँ, सीरियल नंबर देखो, सीरियल नंबर जो तुम बोल रहे हो ना, हाँ अच्छा ठीक है, ठीक ठीक। ठीक है, देखते हैं।
Carbon dioxide gives rise to precipitated calcium carbonate and water. Calcium hydroxide, when added to calcium bicarbonate, gives rise to precipitated calcium carbonate and water. Calcium hydroxide, when added to magnesium bicarbonate, gives rise to magnesium carbonate and precipitated calcium carbonate and water. Calcium hydroxide, when added to magnesium carbonate, gives rise to precipitated calcium carbonate and magnesium hydroxide. Calcium hydroxide, when added to magnesium sulfate, gives rise to calcium sulfate and precipitated magnesium hydroxide. Let's go deeper into the process. Lime addition removes only magnesium hardness and calcium carbonate hardness. If you see in equation number 5, magnesium is precipitated. However, an equivalent amount of calcium is added. The water now contains the original calcium non-carbonate hardness and the calcium non-carbonate hardness produced in equation number 5. Soda ash is added to remove calcium non-carbonate hardness. Sodium carbonate, when added to calcium sulfate, gives rise to calcium sulfate and precipitated calcium carbonate. Keeping the equations in mind, to precipitate calcium carbonate requires a pH of about 9.5 and to precipitate magnesium hydroxide requires a pH of about 10.8. Therefore, an excess lime of about 1.25 milliequivalents per liter is required to raise the pH. The amount of lime required is equal to amount of carbon dioxide in milliequivalents per liter plus carbonate hardness in milliequivalents per liter plus magnesium ion in milliequivalents per liter plus 1.25 in milliequivalents per liter. The amount of soda ash required is equal to non-carbonate hardness in milliequivalents per liter. After softening, the water will have high pH and contains excess lime and also magnesium hydroxide and calcium carbonate that did not precipitate. Recarbonation, that is addition carbon dioxide, is done in order to stabilize the water. The excess lime and magnesium hydroxide are stabilized by adding carbon dioxide, which also reduces pH from 10.8 to 9.5. Carbon dioxide, when added to calcium hydroxide, gives rise to precipitated calcium carbonate and water. Carbon dioxide, when added to magnesium hydroxide, gives rise to magnesium carbonate and water. Further recarbonation will bring the pH to about 8.5 and stabilize the calcium carbonate. Carbon dioxide, when added with calcium carbonate and water, it gives rise to calcium hydrogen carbonate. It is not possible to remove all of the hardness from water. In actual practice, about 50 to 80 mg per liter will remain as a residual hardness. कोविड-19 से आज पूरा देश लड़ रहा है और यात्री अपनी बीमारी से
हाँ
बात करके कॉपी ऑफिस जो हाईवे बिल बनाना है तो बना दीजिए। सुनो ना जी, अभी धनबाद वाले का माल निकाल रहे हैं, ठीक है। कार्लो वाले का कहाँ तक ले जा रहे हो? हम तक ले जा रहे हो ना, कि दीघा तक ले जा रहे हैं? दीघा तक दे दे और कॉन्टेक्ट पर्सन में हम लोग को दे दो, ठीक है। पेमेंट एक्चुअल रखना सब में, ठीक। और अभी जो है ना फिलहाल जो है शंकर मोटर का भी तुम पटना का नया वर्कशॉप के नाम से इनवाइस बना दो, ठीक है। आप यहाँ से कलेक्ट करके गति में चला जाएगा ना, तो गति से प्रूफ मिल जाएगा कि आपको माल दे दिए हैं। अब अगर सोमवार को उसको बताएंगे कि ये एक माल पटना जाएगा या पूर्णिया, ये चेंज भी हो सकता है, तो सोमवार को चेंज भी कर सकते हैं हम लोग, ठीक है। ठीक है, इमरान को तीनों इनवाइस बना के दे दो, ठीक। तीनों माल वहाँ से गति को ही चला, ठीक है। इसमें तीनों ईएल है, ठीक। और नंबर ऑफ पार्सल तीनों में 3 है।
तीनों में ईगल कैसे हो जाएगा? ईगल कैसे हो जाएगा? एक में तो राइसा रहेगा ना।
अबे नंबर ऑफ पार्सल तीनों में बोला 3 है, एक लाइनर में 3 का है,
ठीक।
3 जगह का माल है भाई, शंकर, कार्लो और यहाँ, और तीनों को इनवाइस मेरा नहीं हाथ लगना चाहिए राइसा के छोड़ के, यानी 2 आदमी को।
नहीं लगना चाहिए तो पढ़ना में तुम ही ना उसको ये करोगे।
हाँ वही मेरा ही नंबर डालना और राइट एक्चुअल रखना, तो कॉल कर भी करेगा,
ठीक
ठीक है ना।
Remember the previous session where we ended up with lime soda softening, which takes up a major role in removing the hardness from water. After the softening process, the water undergoes ion exchange, which is an adsorption phenomenon where the mechanism of adsorption is electrostatic. Electrostatic forces hold ions to charged functional groups on the surface of the ion exchange resin. The adsorbed ions replace ions that are on the resin surface on a 1:1 ratio charge basis. As we have now understood the ion exchange phenomenon, let's note down the applications of ion exchange in treatment of DM water and wastewater. Calcium magnesium, that is hardness removal, exchange with sodium or hydrogen. Iron manganese removal from groundwater. Recovery of valuable waste products, silver, gold, uranium. Demineralization, that is exchange all cations for hydrogen ion, all anions for hydroxide ion. Removal of nitrate, ammonium, phosphate, that is nutrient removal. There are many ion exchangers that are used to treat water. Let us see few of them. Natural type of exchangers are proteins, soils, lignin, coal, metal oxides, aluminosilicates, zeolites. Synthetic zeolite gels are most common polymeric resins. Polymeric resins are made in 3D networks by cross-linking hydrocarbon chains. The resulting resin is insoluble, inert, and relatively rigid. Ionic functional groups are attached to this framework. These resins are generally manufactured by polymerizing neutral organic molecules, such as styrene, that is, to form polystyrene, and then cross-linked with divinyl benzene, that is, DVB. Functional groups are then added according to the intended use. For example, the resin can be sulfonated by adding sulfuric acid to get the structure shown. let us know more about the uses of ion exchange resins. The ion exchange resins are used to produce deionized, that is, demineralized water. These resins are small plastic beads that are composed of organic polymer chains that have charged functional groups built into the resin bead. You can clearly see the structure of iron resin bead in this picture. Resin classification. Resins are classified based on the type of functional group they contain and their percentage of cross-linkages. So they are basically of two types: cationic exchangers, anionic exchangers. Cationic exchangers. Strongly acidic in cationic exchangers, which are functional groups derived from strong acids. Weakly acidic in cationic.
अच्छा
जो सीरियल नंबर तुमको देना है उसमें सब कुछ लिखा होगा। इसके अलावा जो सीरियल नंबर मशीन होगा उसको मत छुआ, ठीक है।
ठीक।
इसके अलावा 6 और मशीन है, 6 मशीन को कुछ नहीं करना, ऐसा ही रहने देना।
तीन मशीन निकल रहा है, ठीक है।
क्या बोले?
3 मशीन है, एक रायसा निकल रहा है, एक 2 ठो वहाँ के लिए निकल रहा है, पटना के लिए।
पटना के लिए कौन कौन से निकल रहा है?
कौन सा नहीं, V3DEL ही निकल रहा है।
V3DEL और
तीनों V3DEL ही निकल रहा है, ठीक है ना। 2 पटना के लिए और एक जो है यहाँ के लिए, बोकारो के लिए।
हाँ तो सुनो, उसमें देखो लिखा हुआ है बोकारो के लिए रायसा लिखा हुआ है, एक सीएल के आगे लिखा होगा रायसा, वो रायसा को भेज दो। उसके अलावा और 4 ईयर होगा तो 2 ईयर में, ठीक है।
रायसा, अच्छा हाँ, ठीक ठीक ठीक
ठीक है। और उसके अलावा तो और जो ये 2 मंत्र है वो 2 मंत्र 2 सीरियल नंबर का, ठीक है।
इसमें जो है
और आइडेंटिफाई कर लेना जो सीरियल नंबर, एक सीरियल नंबर ऐसा है जो सीरियल नंबर नहीं दिया, जो वो सीरियल नहीं भेजना है, ठीक है।
अच्छा,
तो ज्यादा महंगा भी का है, उसको अपन करना है, तो वो सीरियल नंबर मैं इसमें नहीं दिया हूँ, तो ध्यान से
तो
एक मशीन में डलवाने सीरियल नंबर वेरीफाई करके डाले का पोर्टल।
अच्छा, तो इसमें से एक काम करते हैं, रायसा और उसके नीचे का जो 2 ठो है वो तीनों दे देते हैं।
हाँ बस जो मशीन है वही सीरियल नंबर का मशीन को शुरू करते हैं।
चलिए ठीक।
इसके अलावा कोई नहीं, वेरीफाई कर लेना, फोटो मंगा के चेक कर लेना, नहीं तो पता चला भेज दिया कुछ और हुआ हो गया अगला।
ठीक है, वैसे ही करते हैं। ओके, थैंक यू।
Cationic exchangers, which are functional groups derived from weak acids. Anionic exchangers. Strongly basic in anionic exchangers, which are functional groups derived from quaternary ammonia compounds. Weakly basic in anionic exchangers, which are functional groups derived from primary and secondary amines. The regeneration of cation and anion exchange resins used in deionizers is a more complicated process than simple softening. Spent or exhausted columns must be regenerated because of the cost of the resin that would make one-time use prohibitive. Since ion exchange is a very reversible process, regeneration can be accomplished by manipulation of solution composition. Let us also see an example. A spent column used to remove calcium cation is to be regenerated in a batch process to the sodium cation form. A strong brine, mostly sodium chloride, is contacted with the exhausted resin to replace calcium with sodium. The strong acid cation exchanger resin is regenerated with sulfuric or hydrochloric acid, which effectively strips off the calcium, magnesium and sodium from the resin, substituting hydrogen. Caustic soda or sodium hydroxide is used to regenerate the anion-resin exchanges of the collected anions for the hydroxide ion in the caustic. The softness removes hardness from water by a process known as ion exchange, and the steps involved are: soften to exhaustion. In this process, the water will be softened. Backwash. In this process, the direction of flow is reversed and the silt, sediment, and iron particles are flushed from the resin. Regeneration. In this stage of regeneration, the brine solution is slowly passed through the resin until the resin retains as much sodium as possible. Rinse. Excess brine is rinsed from the resin. Return to forward flow. The resin bed is compacted for maximum operating efficiency. The water softener then returns to the service cycle. Let us now note down the operating parameters for the softening cycle. Operating parameters. The operating exchange capacity is 0.6 to 1.2 equivalent per liter. Bed depth is 2 to 6 feet. Head loss is 1 to 2 feet. Softening flow is 5 to 10 gallons per minute per square feet. Backwash flow is 5 to 6 gallons per minute per square feet. Salt dose is 3 to 10 pounds per cube feet resin brine. Brine contact time 25 to 45 minutes. Rinse flow 1 to 5 gallons per minute per square feet. Rinse volume 20 to 40 gallons per cube feet resin. Remember, previously we discussed a process called sedimentation, which was explained by Mr. Ashok. Today, he will be telling us about RO.
Thank you, Shreya. Hello everybody. I know that many of you are aware about RO, but it is little different from what you know. So reverse osmosis is a separation process that uses pressure to force a solvent through a membrane that retains the solute on one side and allows the pure solvent to pass to the other side, meaning it allows the passage of solvent but not of solute. In reverse osmosis, the idea is to use the membrane to act like an extremely fine filter to create DM water or drinking water from raw water or sea water. The membranes used for reverse osmosis have a dense barrier layer in the polymer matrix where most separation occurs. In most cases, the membrane is designed to allow only water to pass through this dense layer while preventing the passage of solutes. This process requires high pressure to be exerted on the high concentration side of the membrane, usually 30 to 250 psi for fresh water and brackish water, and 600 to 1000 psi for seawater. Reverse osmosis is used to reduce dissolved solids from feed waters. Let us see the actual working involved in this process. Reverse osmosis is a water purification technology that uses a semi-permeable membrane. This membrane technology is not properly a filtration method. In RO, an applied pressure is used to overcome osmotic pressure. RO can remove many types of molecules and ions from solutions and is used in both industrial processes and in producing potable water. Reverse osmosis works by using a high pressure pump to increase the pressure on the salt side of the RO and force the water across the semi-permeable RO membrane, leaving almost all around 95% to 99% of dissolved salts behind in the reject stream. The amount of pressure required depends on the salt concentration of the feed water. The more concentrated the feed water, the more pressure is required to overcome the osmotic pressure. The desalinated water that is demineralized or deionized is called permeate water. The water stream that carries the concentrated contaminants that did not pass through the RO membrane is called concentrate stream.
Thank you, sir, for the explanation. In our houses and industries, we do have an RO water filter that purifies water. Have you ever thought, how does it work? RO systems commonly come in either single pass or double pass configurations. As the feed water enters the RO membrane under pressure, that is enough to overcome osmotic pressure. The water molecules pass through the semi-permeable membrane, and the salts and other contaminants are not allowed to pass and are discharged through the reject stream, which goes to drain or can be fed back into the feed water supply in some circumstances to be recycled through the RO system to save water. The water that makes it through the RO membrane is called permeate or product water and usually has around 95% to 99% of the dissolved salts removed from it. An RO system employs cross-filtration rather than standard filtration, where the contaminants are collected within the filter media. With cross-filtration, the solution passes through the filter with two outlets. The filtered water goes one way and the contaminated water goes another way. To avoid buildup of contaminants, cross-flow filtration allows water to sweep away contaminant buildup and also allow enough turbulence to keep the membrane surface clean. Learning more about the RO process, let us see what else can be done in the process. Reverse osmosis is capable of removing up to 99% of the dissolved salts, particles, colloids, organics, bacteria, and pyrogens from the feed water. An RO membrane rejects contaminants based on their size and charge. Any contaminant that has a molecular weight greater than 200 is rejected by a RO system. The greater the ionic charge of the contaminant, the more likely it will be unable to pass through the RO membrane. Reverse osmosis is very effective in treating brackish, surface and groundwater for both large and small applications. Some examples of industries that use of RO water include pharmaceutical, boiler feed water, food and beverage, metal finishing, and semiconductor manufacturing. Did you know 300 tons of water is required to manufacture 1 ton of steel? Do you know any device that removes oxygen? Yes, you are right. We will be discussing about deaerator. A deaerator is a device that is widely used for the removal of oxygen and other dissolved gases from the feed water to steam generating boilers. In order to meet industrial standards for both oxygen content and the alloyable metal oxide levels in feed water, nearly complete oxygen removal is required. This can be accomplished only by efficient mechanical deaeration supplemented by a properly controlled oxygen scavenger. Solubility of any gas in a liquid is directly proportional to the partial pressure of the gas at the liquid surface. It decreases with increasing liquid temperature. Efficiency of removal is increased when the liquid and gas are thoroughly mixed. In particular, dissolved oxygen in boiler feed waters will cause serious corrosion damage in steam systems by attaching to the walls of metal piping and other metallic equipment and forming oxides, that is, rust. Dissolved carbon dioxide combines with water to form carbonic acid that causes further corrosion. Most aerators are designed to remove oxygen down to levels of 7 parts per billion by weight, 0.005 cubic centimeters per liter or less, as well as essentially eliminating carbon dioxide. You can see in the diagram to know how deaeration takes place. Talking about the deaerators, there are two basic types of deaerators, the tray type and the spray type. Tray type deaerator. The typical horizontal tray type deaerator has a vertical domed deaeration section mounted above a horizontal boiler feed water storage vessel. Boiler feed water enters the vertical deaeration section above the perforated trays and flows downward through the perforations. Low pressure deaerated stream enters below the perforated trays and flows upward through the perforations. The stream strips the dissolved gas from the boiler feed water and exits via the vent at the top of the domed section. The deaerated water flows down into the horizontal storage vessel from where it is pumped to the steam generating boiler system. Low pressure heating steam, which enters the horizontal vessel through a spouted pipe in the bottom of the vessel, is provided to keep the stored boiler feed water warm. External insulation of the vessel is typically provided to minimize heat loss. The spray type deaerator consists only of a horizontal or vertical cylindrical vessel which serves as both the deaeration section and the boiler feed water storage tank. The typical spray type deaerator is a horizontal vessel which has a preheating section and a deaeration section. The two sections are separated by a baffle. Low pressure steam enters the vessel through a spouter in the bottom of the vessel. The boiler feed water is sprayed into section where it is preheated by the rising steam from the sparger. The purpose of the feed water spray nozzle and the preheat section is to heat the boiler feed water to its saturation temperature to facilitate stripping out the dissolved gases in the following deaeration section. The preheated feed water then flows into the deaeration section where it is deaerated by the steam rising from the sparger system. The gas is stripped out of the water exit via the vent at the top of the vessel. What shall we do if we found out that there are still some oxygen in the water? So, oxygen scavenging chemicals are added to the deaerated boiler feed water to remove any last traces of oxygen that were not removed by the deaerator. The type of chemical added depends on whether the location uses a volatile or non-volatile water treatment program. Lower pressure systems, that is less than 650 psi, use a non-volatile program. Higher pressure systems, that is greater than 650 psi, and all other systems where certain highly alloyed materials are present are now using volatile programs as the old phosphate-based programs go away. The most commonly used oxygen scavenger for lower pressure systems is sodium sulfite. It is very effective and rapidly reacts with traces of oxygen to form sodium sulfate, which is non-scaling. Another widely used oxygen scavenger, properly diluted and for locations using volatile programs, is hydrazine. However, hydrazine is carcinogen. Other scavengers include carbohydrazide, diethyl hydroxylamine, nitrilotriacetic acid, ethylene diamine tetracetic acid, and hydroquinone. Since we have an idea of what is happening exactly in the water treatment till now, let us check out the overview of the DM plant. In industrial water treatment, demineralization refers to the removal of dissolved solids from the feed water and process streams. What is water demineralization? Demineralization is a type of water purification, while it can refer to any treatment process that removes minerals from water. The term demineralization is typically reserved specifically for an ion exchange processes used for near total removal of ionic mineral contaminants. Let us get deeper into the topic by knowing about the procedure involved at Powerhouse 5 of Tata Steel as a case study. At DM water plant at pH 5, clarified water from river pump house enters into dual media filter for primary filtration of suspended solids in water. Anthracite and sand are filtering medium in dual media filter. Before receiving it at dual media filter, also called DMF, coagulant, that is ferric chloride FeCl3, and oxidant, that is sodium hypochlorite NaOCl, are added for coagulation and disinfection. Then water from DMF enters into a contact tank of 100 cubic meter volume. Here, retention time is allowed for reaction to complete with coagulant and disinfectant. Filter feed water pumps, that is, 2 working and 1 standby, transfers this water to 3 number of pressure sand filters, that is, PSF, for secondary filtration. This filter has fine sand as filtration medium. DMF and pressure sand filter, also called PSF, together remove most of suspended solids from water. Water from secondary filtration units, that is PSF, passes through 5 micron cartridge filters. Total suspended solid, which is called TSS, is completely removed here. 2 high pressure booster pumps send water from cartridge filters to reverse osmosis, where RO membrane removes dissolved solids. Dissolved solid is removed here from water to great extent. Water from RO then goes to degasser water tower to remove dissolved carbon dioxide. Degassed water is then stored in degasser water storage tank. Now, water is pumped from degasser water storage tank to mixed bed filled with 2 types of resins. Here, ion exchange takes place and total dissolved solid is completely removed. Water thus achieved is demineralized water, which is stored in DM water storage tank, from where it is sent to boiler as per need. RO reject water and backwash water from primary and secondary filters is collected in neutralization pit, where it is neutralized using hydrochloric acid or sulfuric acid and caustic, that is sodium hydroxide, as per norms. This water is finally discharged to upper cooling pond. Do you know that there are tiny microorganisms in the water we drink that cannot be seen through naked eye? How do we then keep us safe? Disinfection is an important step in ensuring that water is safe to drink. Water systems add disinfectants to destroy microorganisms that can cause disease in humans. The surface water treatment rule requires public water systems to disinfect water obtained from surface water supplies. Primary methods of disinfection are chlorination, chloramines, ozone, and ultraviolet light. Other disinfection methods include chlorine dioxide, potassium permanganate, and nanofiltration. Since certain forms of chlorine react with organic material naturally present in many water sources to form harmful chemical byproducts that are carcinogens, maximum levels for those contaminants should be kept low in water. There are 2 kinds of disinfection. Primary disinfection achieves the desired level of microorganism kill or inactivation, while secondary disinfection maintains a disinfectant residual in the finished water that prevents the regrowth of microorganisms. Click on the different tabs to know more. There are many processes involved in removing pathogens and microorganisms from water. Let's learn about it one by one by discussing its advantages, limitations, process, equipment, and chemicals involved. The first process in chlorination. Chlorination gas. At normal pressures, elemental chlorine is a toxic yellow-green gas and is liquid at high pressures. Advantages. Chlorine is very effective for removing almost all microbial pathogens. Limitations. Chlorine is a dangerous gas that is lethal at concentrations as low as 0.1% air by volume. Process. Chlorine gas is released from a liquid chlorine cylinder by a pressure reducing and flow control valve operating at a pressure less than atmospheric. The gas is led to an injector in the water supply pipe where highly pressurized water is passed through a venturi orifice, creating a vacuum that draws the chlorine into the water stream. Adequate mixing and contact time must be provided after injection to ensure complete disinfection of pathogens. It may be necessary to control the pH of the water. Equipment. A basic system consists of a chlorine cylinder, a cylinder-mounted chlorine gas vacuum regulator, a chlorine gas injector, and a contact tank or pipe. Prudence or state regulations would require that a second cylinder and gas regulator be provided with a changeover valve to ensure continuity of disinfection. Additional safety and control features may be required. A gas chlorinator should be installed in a room or chamber with direct emergency access to outside air and fitted with an exhaust fan ventilation system. Statutory safety regulations must be observed. If not on-site, self-contained breathing apparatus and a chlorine cylinder repair kit should be available within a reasonable time frame or distance. Chemicals. Chlorine gas is supplied as liquid in high pressure cylinders. Click on the different tabs to know more. The second process of chlorination is based on using sodium hypochlorite solution. It is available as a solution in concentrations of 5 to 15% chlorine. Advantages. It is easier to handle the gaseous chlorine. Limitations. Sodium hypochlorite is very
हाँ बोलो नहीं, अभी ईवे बिल भी नहीं कर रहे हैं। अरे लॉगिन ही नहीं हो रहा था, अभी हुआ लॉगिन। तो मेल आईडी पे भेजना है उसको। चलो ठीक है, ठीक है, मेल आईडी पे भेजते हैं। ठीक। हाँ, 2 पटना का है, एक दीघा का है, एक वहाँ अली नगर का है, और एक जो है यहाँ का है। 2 जगह फाइनल हुआ, तीसरा जो है वो जो ऑफिस जो बनाया है वहाँ का हम एड्रेस डाल दिए। अब वहाँ से जहाँ भी जाना होगा चला जाएगा, पटना पहुँच जाओ। अब छोड़ो, रहने दो, कितना बार वही करते रहे। अरे यार, उसका अभी कंफर्म नहीं हुआ है, वहाँ से कंफर्म होगा तब तो अब ओनर को बात। तो जब माल लेके आया तो तुम कंफर्म हो गया ना कि 2 ही जगह जाना है। अब देखो, अभी कौन आएगा वहाँ पर से ये लेने के लिए? रांची में कौन जाएगा उसको देने के लिए और क्या करने के लिए? तो कहाँ? एक मिनट, वो वहाँ से पिकअप नहीं कर रहा है वो? अच्छा अच्छा। अच्छा, तुम गति में हब में पहुंचा दे रहे हो, उसके बाद जो है वो। अच्छा, तो अभी मतलब 2 ही। ठीक है, ठीक।
तुम्हाला ज्या व्यक्तीस कॉल करीत आहात ती व्यक्ती उत्तर देत नाही. कृपया थोड्या वेळानंतर पुन्हा प्रयत्न करा. The person you are calling is not out. आपण ज्या नंबरवर संपर्क करण्यास प्रयत्न करत आहात तो यावेळी संपर्क क्षेत्रामध्ये नाही किंवा बंद आहे. कृपया थोड्या वेळानंतर प्रयत्न करा. आप जिस नंबर पर your calling is out of network coverage area. Please try.
अस्सलाम वालेकुम.
हेलो.
हाँ अस्सलाम वालेकुम.
वालेकुम सलाम. बोलिए.
तो चलिए ना, ये इसका ईवे बिल का वो खुल नहीं रहा है मेरे से, तो आप ईवे बिल 200 निकाल सकते हैं क्या?
कहाँ? अभी तो नहीं है ऑफिस में.
तो मेरे तो मोबाइल से नहीं निकलेगा.
वो तो हम कहाँ थोड़ी ना हम निकालते हैं. तो सारे ही निकालेंगे.
सर का फोन स्विच ऑफ आ रहा है.
तो अभी नहीं होंगे चाहिए. ईवे बिल अभी सब चालू है अभी.
हाँ भाई चालू है, माल वही है, राशि में ही है.
काम चालू हो रहा है आपका?
हाँ मतलब स्टार्ट कर दिया ना.
और अप्रैल मंथ में हुआ था?
अप्रैल में नहीं हुआ था, मई में हुआ है.
अप्रैल में 0 है.
0 है.
परचेस लोन हो.
हाँ.
और मई में?
मई में है, मई में 7-8 पीस है.
वो परचेस हुआ है.
परचेज नहीं हुआ, सेल हुआ.
परचेस तो पहले वाला ही था.
हाँ पहले वाला है.
अभी तो नहीं है.
तो आप कुछ नहीं कर सकते हैं?
हम कैसे करेंगे अभी तो घर में.
नहीं, जैसे कुछ थोड़ा देख लीजिए, हो सकता है.
अभी कहाँ से देखेंगे? कैसे देखेंगे? अभी तो अभी क्या रहता है ना.
नहीं, मेरे पास आईडी पासवर्ड है, ठीक है, बोलिएगा ना.
सारे करते हैं, हम नहीं करते.
चलिए ठीक है.
कहाँ है आप?
घर पे ही है. हाँ उन लोग रांची में है.
अभी तो हल्का स्टार्ट हुआ है थोड़ा बहुत घर तब मतलब पेंटिंग ही हो रहा है. अभी डेट और बढ़ा दिए चाहिए थोड़ा बहुत कर रहे हैं.
तो कब तक डेट आया है जीएसटी में? 9 मार्च वाला.
अभी तो नहीं बता सकते हैं, बस चल रहा है. इसका डेट कब है क्या है तो नहीं बता सकते.
चलिए ठीक है.
ठीक हो.
कोरोना वायरस या कोविड-19 से आज पूरा देश लड़ रहा है, पर याद रहे हमें बीमारी से लड़ना है.
हाँ बोलो. अच्छा सुनो ना, मेरे इससे खुल नहीं रहा है, ठीक है. ये क्या नाम है, तो इसको हम इनवाइस हम भेज देते हैं मेल पे तुम लोग को, ठीक. अरे मेल पे इनवाइस भेज देते हैं, गति वाले को बोलो कि वो निकालने के लिए क्या नाम है ईवे पे हम तुमको हम टेक्स्ट कर दे रहे हैं, मैसेज कर दे रहे हैं, ठीक है. आउटबाउंड। अच्छा सुनो ना, ये जो सीरियल नंबर जो दिए हैं वही सीरियल नंबर निकाल के लाए हो ना? उनको काफी हम बोले थे 1 घंटा 1.5 घंटा पहले, क्या बोले थे? पुराना वाला तो सीरियल नंबर हम बोला था ना कि मिला, तो फिर उसका तुम बोले थे कि सीरियल नंबर आप निकाल करके दीजिए हैं? अरे पुराना वाला निकालोगे, सीरियल नंबर पुराना वाला का ही करना, सीरियल नंबर उसमें मिला लेना, ये बात बोले थे कि नहीं बोले थे? अरे यार तो फिर तुम हमको बोले थे कि सीरियल नंबर हम इसमें मिलाइएगा, आप मेरे देखिएगा, हम भेजे हैं तो आप तो निकाल करके हम भेजे ना तुमको। मैसेज किया यार, अब मैसेज करने के बाद भी अब हम क्या करने के बाद फिर से हम हाइक करके सबको फोन किया करें? तो वैसे तो मेरा भी 12% है, अब हम क्या हम बोले? अब तो 1 घंटा पहले ही हम मतलब उसको मैसेज 3 सीरियल नंबर दिए हैं, ठीक है ना? फोन किसमें जाएगा उसका, ठीक है? अब जो कह करो। हाँ बोलो। आप जो सीरियल नंबर मेरे को दिया है 489 492 504 ईसीएम नंबर निकाला तीनों वही है या मतलब अलग अलग है? वही है, तीनों वही है, तीनों सेम है। ठीक है ठीक है ठीक।
Very corrosive and should be stored with care and kept away from equipment that can be damaged by corrosion. Process. The solution is diluted with water in a mixing or holding tank. The diluted solution is injected by a chemical pump into the water supply pipe at a controlled rate. Equipment. A basic liquid chlorination system or hypochlorinator includes 2 metering pumps, that is, one serving as a standby, a solution tank, a diffuser, that is, to inject the solution into the water, and tubing. Chemicals. Sodium hypochlorite solution is readily available. Sodium hypochlorite can also be generated on-site by electrolysis of sodium chloride solution in specialized proprietary equipment. The only supplies required are common salt and electricity. Hydrogen is given off as a byproduct and must be safely dispersed. Click on the different tabs to know more. The third process of chlorination is based on using solid calcium hypochlorite. Calcium hypochlorite is a white solid that contains 65% available chlorine and dissolves easily in water. Advantages. When packaged, calcium hypochlorite is very stable, allowing a year's supply to be bought at one time. Limitations. Calcium hypochlorite is a corrosive material with a strong odor that requires proper handling. It must be kept away from organic materials such as wood, cloth, and petroleum products. Reactions between calcium hypochlorite and organic material can generate enough heat to cause a fire or explosion. Calcium hypochlorite readily absorbs moisture, forming chlorine gas. Therefore, shipping containers must be emptied completely or carefully resealed. Process. Calcium hypochlorite must be dissolved in a mixing or holding tank and injected in the same manner as sodium hypochlorite. Alternatively, where the pressure can be lowered to atmospheric, such as at a storage tank, tablets of hypochlorite can be directly dissolved in the free-flowing water by a proprietary device that provides flow proportional chlorination with gravity feed of the tablets. Equipment. The equipment used to mix the solution and inject it into the water is the same as that for sodium hypochlorite. Solutions of 1 or 2% available chlorine can be delivered by a diaphragm type chemical feed or metering pump or by tablet chlorinator. Chemicals. Calcium hypochlorite can be purchased in granular, powdered or tablet form.
Click on the different tabs to know more.
The next process of disinfection is based on using chloramine. Chloramines are formed when water containing ammonia is
देखभाल करें और इस बीमारी से बचने के लिए जो हमारी ढाल है, जैसे हमारे डॉक्टर, स्वास्थ्यकर्मी, सफाई कर्मचारी, पुलिस आदि, उनका सम्मान करें, उन्हें पूरा सहयोग दें। इन योद्धाओं की करो देखभाल तो देश जीतेगा कोरोना से। हर हाल। अधिक जानकारी के लिए स्टेट हेल्पलाइन नंबर 104 या सेंट्रल हेल्पलाइन नंबर 1075 पर संपर्क करें। भारत सरकार द्वारा जारी। आप जिस व्यक्ति को कॉल कर रही है वह उत्तर नहीं दे रही है। बीमारी से बचने के लिए
chlorinated or when ammonia is added to water containing chlorine. Advantages. An effective bactericide that produces fewer disinfection byproducts. Chloramine is generated on site. Usually, chloramine forming reactions are 99% complete within a few minutes. Limitations. Chloramine is a weak disinfectant. It is much less effective against viruses or protozoa than free chlorine. Chloramine is appropriate for use as a secondary disinfectant to prevent bacterial regrowth in a distribution system. Nitrogen trichloride appears to be the only detrimental reaction byproduct. It may be harmful to humans and imparts a disagreeable taste and odor to the water. The use of the proper amounts of each chemical reactant will avoid its production. Process. Chlorine is injected into the supply main followed immediately by injection of ammonia. As before, adequate mixing and contact time must be provided. The mix of products produced when water, chlorine and ammonia are combined depends on the ratio of chlorine to ammonia and the pH of the water. Chlorine to ammonia ratios of 5:1 should not be exceeded. If the pH drops below 5, some nitrogen trichloride may be formed. Equipment. The generation of chloramines requires the same equipment as chlorination plus equipment for adding ammonia. Chemicals. Chemicals used to generate chloramine from ammonia and chlorine gas depend on the ammonia-based chemical used. Anhydrous ammonia is the least expensive, while ammonium sulfate is the most expensive.
हमारे ढाल है जैसे हमारे डॉक्टर स्वास्थ्य कर्मी सफाई कर्मचारी पुलिस आदि उनका सम्मान करें doctors, healthcare workers, sanitation workers, police officers.
Click on the different tabs to know more.
The next process of disinfection is ozonation. Ozone, an allotrope of oxygen, having 3 atoms to each molecule, is a powerful oxidizing and disinfecting agent. It is formed by passing dry air through a system of high voltage electrodes. Advantages: requiring shorter contact time and dosage than chlorine. Ozone is widely used as a primary disinfectant in many parts of the world. Ozone does not directly produce halogenated organic materials unless a bromide ion is present. Limitations: ozone gas is unstable and must be generated on-site. A secondary disinfectant, usually chlorine, is required because ozone does not maintain an adequate residual in water. Process: the 5 major elements of an ozonation system are air preparation or oxygen feed, electrical power supply, ozone generation, usually using a columnar discharge cell consisting of 2 electrodes, ozone contact chamber, and ozone exhaust gas destruction. Ozonation equipment includes air preparation equipment, an ozone generator, contactor, destruction unit, and instrumentation and controls. The capital costs of ozonation system are relatively high. Operation and maintenance are relatively complex. Electricity represents 26 to 43% of total operating and maintenance costs for small systems. Chemicals. For many applications, pure oxygen is a more attractive ozone feed gas than air because it has a higher production density.
अच्छा सुनिए ना, ये आएगा ना तो बोलिए कि आउटबाउंड वाला डील किया किया जाता है, वो आउटबाउंड वाला किया नहीं तो इसके लिए वो आप इंक्रीज कर दीजिएगा बिल को।
It requires lower energy consumption. It doubles the amount of ozone that can be generated per unit, and it requires smaller gas volumes for the same ozone output, thus lowering costs for ancillary equipment.
Click on the different tabs to know more.
The large process of disinfection is based on using ultraviolet light, that is UV. Ultraviolet UV radiation is generated by a special lamp. When it penetrates the cell wall of an organism, the cell's genetic material is disrupted and the cell is unable to reproduce. Advantages: UV radiation effectively destroys bacteria and viruses. As with ozone, a secondary disinfectant must be used to prevent regrowth of microorganisms. UV radiation can be attractive as a primary disinfectant for small systems because it is readily available. It produces no known toxic residuals. It requires short contact times and the equipment is easy to operate and maintain. Limitations: UV radiation may not inactivate Giardia lamblia or cryptosporidium cysts and should be used only for groundwater systems. Not directly influenced by surface water, where there is virtually no risk of overgrown cyst contamination. UV radiation is unsuitable for water with high levels of suspended solids, turbidity, color, or soluble organic matter. These materials can react with or absorb the UV radiation, reducing the disinfection performance. Process: the effectiveness of UV radiation disinfection depends on the energy dose absorbed by the organism, measured as the product of the lamp's intensity, that is, the rate at which photons are delivered to the target, and the time of exposure. If the energy dosage is not high enough, the organism's genetic material might only be damaged instead of destroyed. To provide a safety factor, the dosage should be higher than needed to meet disinfection requirements. Equipment: UV lens and a reactor. Chemicals: no chemical oxidant required. Therefore, microorganisms can be killed without generating byproducts of chemical oxidation or halogenation.
उसका पता नहीं बाउंस किया बाउंस बैक किए तुम अपने में से निकाल दो ना यार तुम भी तो मेरे पे हो ना ठीक है
Click on the different tabs to know more.
As we have come to end of the module, I believe that there are so many things to remember. Can we brush up once what we have learned till now? Definitely. Let's note down the important points. A bar screen is a mechanical filter used to remove large objects such as rags and plastics from wastewater. To achieve good coagulation, a high energy is required to properly disperse the coagulant and particle collisions. The purpose of sedimentation here is to decrease the concentration of suspended particles in the water, reducing the load on the filters. Basins are useful because raw water entering the plant from a reservoir is usually more uniform in quality than water entering the plant without a basin. The important part of a water filtration is the pressure filter, which plays a major role in water treatment. Granular activated carbon is widely used to remove chlorine from main water supplies. Ion exchange is an adsorption phenomenon where the mechanism of adsorption is electrostatic. In reverse osmosis, the idea is to use the membrane to act like an extremely fine filter. Oxygen scavenging chemicals are very often added to the deaerated boiler feed water to remove any last traces of oxygen that were not removed by the deaerator. Disinfection is an important step in ensuring that water is safe to drink. Water systems add disinfectants to destroy microorganisms that can cause disease in humans.
हाँ बोलो।
देखो मेरे भेजना नहीं है, मेरे पास डाउनलोड नहीं हो रहा है, हमको व्हाट्सएप पे
ठीक ठीक
डाउनलोड हो ही ना रहा है।
ठीक।
Now that you have completed the module, it's time for you to check your knowledge by answering these questions.
व्हाट्सएप उड़ा दिया है क्या इसमें से?
किसमें था
कराची में बहुत सारी चिट्टियां पकड़ी है, बहुत आ गई है, तो हमारे जो बंगाली दोस्त रहते हैं उन्हें पकड़ के खा ली। अच्छा किया,
हलाल है
क्यों हो गया? हमारे साथ गैर मुस्लिम के साथ खाना खा सकते, क्यों नहीं खा सकते? छोटी छोटी बातों में फहम भी न पड़ो।
नहीं यार, ऐसे कौन हो रहा
यहाँ
वहाँ कौन हो जाता है? लेक्चर में लगा
3% भी
लेक्चर अगर पूरा वर्क खराब हो जाएगा No, they got a jacket.